Hello students! Previously, we have learnt in detail about hydrocarbon compounds like alkanes, alkenes and alkynes. Now let us learn about the physical properties of these compounds. Carbon compounds generally exist in all three states: solid, liquid and gaseous. Lower carbon compounds, that is compounds containing 10 or fewer carbon atoms, are in gaseous form at room temperature. For example, methane, ethane, propane are all gases. Some carbon compounds like alcohols, ethers and esters also exist in liquid state, while some like paraffin waxes or naphthalene etc. exist as solids. Note that compounds that exist as solids have very long and complex chain structures, which is not true always but generally. Most carbon compounds are colorless and odorless. That is, they don't have smell. Examples are methane and ethane. Carbon compounds usually have relatively low melting points due to the weak intermolecular attraction force. That is, the force between two molecules is less. And reason is that they do not have crystal structures just like ionic compounds have. Methane or ethanol cannot form crystals like that of our common salt, NaCl does. Now what if I tell you that a single covalent bond requires more energy to break than a single ionic bond? So you'll say that I just said that the melting points of organic compounds are lower, and now I'm saying that organic compounds require more energy to break their bonds as compared to ionic ones. How is this possible? Let me help you. You need to understand here that while talking about boiling points and melting points, we always talk about intermolecular force of attraction. That is attraction between two molecules. And when I said that covalent bonds in the organic compounds require more energy to break as compared to the ionic bond, we are referring to the bonds within that molecule or intramolecular bonds. So there is a difference between intermolecular force of attraction and intramolecular force of attraction. Now you know that ionic compounds form crystal networks where a positive ion can be surrounded by as many as 6 negative charges. Due to this, the ionic bond stabilizes and becomes very strong, while this is not the case with organic compounds. Their intermolecular force is very weak and thus they do not form crystal structure. And that is why they melt very easily or boil very easily. Thus, the melting point of an hydrocarbon compound will be lower than the melting point of an ionic compound. For example, sugar, which is an aldehyde containing carbon compound, will melt much more easily than ionic compound salt. However, the individual covalent bonds in sugar contain more energy than the individual ionic bonds in salt. Also, the boiling points of carbon compounds are relatively low. Now again, one of the reasons is the intermolecular force of attraction that exists between these molecules. But there is one more factor which determines the boiling point of carbon compounds. And it is length of carbon chain and branching present on the carbon chain. As the intermolecular forces are less in hydrocarbon compounds as compared to ionic compounds, we observe that the boiling point of carbon compound increases with the increase in number of carbon atoms in the chain. This is because as the length of carbon chain increases, the surface area of the compound will also increase. So the increase in surface area increases the ability of individual molecules to attract each other. And thus, the intermolecular attraction force increases. Now it takes more energy to overcome this force of attraction, and so the boiling point rises. With the rise in carbon atoms in the chain, thus we can say that boiling point is directly proportional to the length of the chain of a compound. So can you tell me which of the following will have a higher boiling point? That's right. Hexane will have the higher boiling point. Butane will have lower boiling point since it has fewer C atoms, that is 4, while hexane will have a higher boiling point since it has more carbon atoms, 6. So the increasing order of these boiling points are like this. Boiling points, as we said, also depends on branching present on the main chain. Branching on the chain decreases the surface area, thereby decreasing the attractive force between individual molecules. And as a result, the boiling point decreases as the number of branches increases. Which of the following do you believe will have the lowest boiling point? Pause the video and think about it. Look at all these compounds carefully. They all have 6 carbon atoms, isn't it? Yes. But all of them have different number of branches of methyl group. This compound doesn't have any branches. It's a straight chain and thus will have the lowest boiling point. While this compound has 2 branches and thus will have higher boiling point. So we can say that as the branches increase, the boiling point of hydrocarbon compound decrease. That is, boiling point is inversely proportional to the number of branches present on the chain. Now most of the hydrocarbon compounds are insoluble in water. And what is the reason for this physical property? The reason for this is that hydrocarbon compounds are non-polar and water is a polar solvent, as we all know it. Almost all of the polar compounds are soluble in water, but non-polar ones are not. And can you think of one example? Yes, correct. It is oil. As we know, oil is one hydrocarbon compound. It has long chain of hydrocarbons. And when it is mixed with water, we'll see that it forms a layer above the water and does not mix with it. So thus, non-polar hydrocarbon compounds are insoluble in water. So we have seen some of the physical properties of hydrocarbon compounds. We are also interested in knowing about their chemical properties. And what are these? See you in the next video.